All right, learning target 2 in logarithms is I can use the change of base formula to solve logarithmic equations. The change of base formula, that is the big deal here. We practiced in the first learning target how to change things from exponential to logarithmic form. And then we were pretty easily able to figure out what the variable was based on that. However, these here are not going to be as easy because they're not as straightforward. Let's look at this guy here. 2 to what power is equal to 10? And we looked at this in the last video a little bit. We know 2 squared is 4, 2 to the third is 8, and 2 to the fourth is 16, which means our answer is somewhere in between 3 and 4 because 10 is in between 8 and 16. So what I'm going to say is x is less than 4 but greater than 3. It's going to be a decimal. I don't know what decimal it is. It's probably going to be pretty gross. I have no idea. But that's going to be my estimate. Something in between 3 and 4. So let's talk about this guy. 3 to what power is equal to 12? Well, I know that 3 squared is 9, which is too low, and 3 to the third is 27, which is too high. I do not know exactly what the exponent is, but I do know it's in between 3 and 2. It's a decimal. It's going to be 2 point something, 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 something. If you want, you could guess and check further, but I just want you guys right now just to do an estimate. Let me know what it's in between. So let's talk about, I'm going to set those up. Let's talk about this guy. 5 to what power is equal to 100? 5 squared is 25. 5 to the third is already way too high. 100 is somewhere in between there. So I know it's in between 2 and 3. This exponent is 2 point something. I don't know exactly what. We could guess and check if you wanted to. I could show you how that works. I could say, I'm trying to get to 100, so that's not high enough. Not high enough. Oops. Not high enough. 2.9. Ooh, that's too high. So now I know even further, it's in between 2.8 and 2.9. But I could sit here, you guys, for hours. I don't know, 8.3. Not high enough. 5. I could sit here for hours and hours. Not high enough. 2.88. Too high. So now I know it's in between. You can just keep narrowing it down. So that's why I just want you guys to do integers. What's the last one here? 4 to what power is 80? Okay, let's get these guys gone. Because now I want my base to be 4. Oops. No. Ooh, still not high enough. Too high. So the exponent here is going to be in between 3 and 4. 3 and 4. That's where the exponent is going to be. There is a way. There is a way to figure out the exact decimal with your calculator. How we do that is we use something called the change of base formula. This is how it works. If I have log base B A equals X, this is the change of base formula. I am allowed to change it to log A over log B equals X. And this is going to be helpful. The reason why this is helpful is because our calculators can do plain logs like this. These logs, let's talk about it. Log A. This log looks like it is missing a base because there is no base listed. However, it is not missing a base. It is a base 10. We just don't write the base 10. And the reason why this is so cool is because our graphing calculators can do log base, it automatically does log base 10. So this is a base 10 right there. What we can't do is type in, like if I wanted to type in, if I wanted to type in this into my calculator, I could not do it because I can't get that little subscript there. But what I can type into my calculator is log 2 over log 4. Those two expressions are equal, and this is going to be what gets us our answer because we don't have the capabilities to type that in. Okay? So let's practice writing using change of base formula. And first thing we need to do is get these into logarithms. So log base 2, remember how this works, 10 equals X. This we cannot type this into our calculator. But what we can type into our calculator is you go log 10, you always do the big number first on top, over log 2. This is our answer. That is how you do the change of base formula. Let's try another. Log base 3, 12 equals X. We cannot type this into our graphing calculator. So we use the change of base formula, log big number over log 3. And that is how you can say equals X if you want. This is what we type in to our graphing calculator or to Desmos. Let's try another. Log base 5, 100 equals X. Log 100 over log 5. And then log base 4, 80 equals X. You rewrite it going log 80 over log 4. And I'm going to show you how cool this is. Remember this problem here where we tried to figure out what is the exponent for 5 to what power is 100. And I think, if I remember right, nope, that was too small. 5 to the power of 2. Remember how we did this? That's too big. That's all. That's great. We can keep guessing and checking. But if you go here, I bet we can find an answer, an actual answer, if we type this in here. This is going to tell me what the exponent needs to be here on the 5 to get 100. So I'm going to go back and I type in log 100. Hopefully our answer is in between 2.8 and 2.9. Yes, it is. The actual exponent to get to 5 to what power is 100 is 2.86135311615. So that's what change of base does for us. So what we're going to do is we're going to do a lot of practice, you guys. We're going to do the first 8 together, and then you guys are going to do the last 8 on your own and check your work. Evaluate using the change of base formula. Log base 210 equals x. So we type in log 10 over log 2. And what is that exponent going to be? 3.32. I'm just going to round to the 2 spots. That is approximately what that exponent needs to be so that you get a 10. Cool? Let's keep practicing. Log base 3, 12 equals x. You guys are going to need your graphing calculator for this, or a calculator. Log 12 over log 3. About 2.26. Feel free. So this needs to be about 2.26. Feel free, you guys, to pause the video. Oh, we already did this one, didn't we? What was that? We had to type in log 100 over log 5. And didn't we get 2.86 approximately? I think we did. Log 80 over log 4. So what is the exponent on that 4 so that we get 80? 3.16. All right, actually, I'm only going to do the first 4. What I want you guys to do is the rest of them. So I'm going to pause this, and I'm going to go ahead and figure out the rest of these, and I would like you guys to do the same and then come back and check your answers, please. All right, here we go. I split my screen. Here are the answers, you guys. A couple of things on the bottom row. There was one that was called undefined, which means it cannot happen. That is not possible, but the calculator will tell you if it's undefined or not, and it does. Please take some time, pause here, check your work. Good luck on your quiz.